The night sky has always been a canvas of dreams, a vast tapestry where every twinkling light tells a story older than humanity itself. For centuries we've gazed upward, weaving myths and science around the stars. Among them, one star has always stood out, not just for its brilliance but for its enigma. Betelgeuse, the fiery red giant in Orion's shoulder, has been a beacon of wonder. Its ruddy glow a constant in the night. But recently it's been anything but constant. It's been flickering, fading, teasing us with the possibility that it might explode in a supernova so bright it could rival the moon. And now, thanks to a marvel of human ingenuity called the James Webb Space Telescope, we're seeing Betelgeuse like never before, a turbulent, chaotic giant that's rewriting everything we thought we knew about the lives and deaths of stars. In a small observatory nestled in the mountains, Dr. Aisha Khan adjusts her telescope, her breath fogging in the chilly night air. She's been watching Betelgeuse for years, ever since she was a child staring at the stars through her father's old binoculars. Back then, it was just a bright red dot that sparked her imagination. Now, it's the focus of her life's work. She's one of thousands of astronomers worldwide who've been captivated by Betelgeuse's recent behavior. A few years ago it started to dim. A star that massive, 1,400 times the size of our sun, doesn't just fade without reason. The astronomical community buzzed with theories. Was it about to explode? Was this the prelude to a supernova that would light up our skies for weeks? Aisha couldn't resist the pull of that mystery. Night after night she tracked its brightness, her heart racing with every dip and flare, across the globe. In a bustling control room, engineers and scientists huddle around glowing screens, their eyes fixed on data streaming in from the James Webb Space Telescope. The JWST, a golden-eyed marvel orbiting 1,000,000 miles from Earth, is humanity's most ambitious attempt to unravel the universe's secrets. Its 6.5-meter mirror, coated in gold to capture the faintest infrared light, can peer through cosmic dust and sea stars and galaxies hidden from other telescopes. For months, the team had waited to turn its gaze toward Betelgeuse. The star's erratic behavior, dimming, brightening, dimming again, had left everyone puzzled. Telescopes on Earth could only do so much. They needed JWST's clarity to cut through the mystery. When the first images arrive, the control room falls silent. Aisha, patched in via video call from her observatory, leans closer to her screen. The image of Betelgeuse isn't the smooth, glowing orb she'd imagined. It's a roiling, turbulent beast, its surface alive with massive hotspots and glowing patches that shift like storms on a gas giant. This isn't a star quietly fading into oblivion. It's a cosmic titan in upheaval, ejecting vast plumes of gas and dust in explosive outbursts. These stellar mass ejections, the team realizes, are the key to Betelgeuse's strange behavior. The star isn't dying, yet it's shedding its outer layers, casting them into space like a sculptor reshaping clay. The clouds of material cool and drift, sometimes blocking Betelgeuse's light from Earth, creating the illusion of a fading star. Aisha feels a thrill run through her. This is no ordinary discovery. It's a glimpse into the chaotic heart of a star that's been a fixture in human culture for millennia. Betelgeuse, named from the Arabic Yod Eliauza, meaning the hand of Orion, has inspired poets, navigators, and astronomers across civilizations. Its vivid red hue, visible even to the naked eye, made it a symbol of power and mystery. But now JWST is showing it in a new light. Literally, its infrared vision reveals details no one could have anticipated. Enormous convection currents, loops of plasma rising and falling, and eruptions so massive they dwarf entire solar systems. Aisha can't help but wonder, what does this mean for Betelgeuse's future? Is it on the verge of a supernova, or is it caught in a prolonged tantrum that could last centuries? In a university lecture hall, Professor Miguel Torres addresses a room full of students, his voice brimming with excitement. He's been studying massive stars for decades, and Betelgeuse's latest revelations have him rethinking everything. He pulls up JWST's images on a projector, and the students gasp. The star's surface looks like a boiling cauldron, with bright patches flaring and fading in weeks, astonishingly fast for something so vast. Miguel explains that stars like Betelgeuse don't follow a neat, predictable path to their end. For years, scientists thought massive stars lived stable lives, before collapsing in a sudden, cataclysmic explosion. But Betelgeuse is showing that the road to a supernova might be far messier, marked by violent outbursts that reshape the star and its surroundings. Miguel's students lean forward, captivated. He tells them how Betelgeuse's eruptions are hurling heavy elements, carbon, oxygen, iron, to space. These are the building blocks of planets, atmospheres, and even life. Every atom in their bodies, he says, was forged in the heart of a star like Betelgeuse, released in its death throes millions or billions of years ago. The students exchange glances, awed by the connection. Betelgeuse isn't just a distant star, it's part of their story, part of the cosmic cycle that made them possible. Miguel points out that when Betelgeuse finally explodes, it will scatter even more of these elements, seeding the galaxy with the raw materials for new stars and planets. It's a reminder that destruction and creation are two sides of the same cosmic coin. Back in the control room, Dr. Li Wei, a lead scientist on the JWST project, pores over the telescope's spectral data. The infrared readings show not just what Betelgeuse looks like, but what it's made of. The star's outer layers are rich with complex molecules, forged in its fiery core and now being cast into space. Li Wei's team is particularly intrigued by the asymmetrical clouds of dust and gas surrounding Betelgeuse. These aren't uniform shells, as older models predicted, but irregular, sprawling veils that shift and twist. The data suggests these clouds are interacting with the interstellar medium, the thin gas between stars, potentially triggering new star formation in the distant future. Li Wei feels a surge of pride. JWST was built for moments like this too. Reveal not just the beauty of the cosmos but its underlying mechanics. Aisha, still at her observatory, starts crunching numbers. She's trying to model what Betelgeuse's eruptions mean for its timeline. Some astronomers believe the star could explode within decades, a blink in cosmic terms. Others think it might linger in this unstable phase for centuries, even millennia. The truth is, no one knows. Betelgeuse is a red supergiant, a star in its final evolutionary stage, but its behavior is unlike anything in the textbooks. Aisha's simulations suggest that the star's massive convection currents, rivers of plasma wider than Earth's orbit, are driving these eruptions. Magnetic fields, possibly tangled and chaotic, might be amplifying the instability. She sends her findings to Li Wei's team, hoping JWST's next observations can confirm her theories. In a small town, a group of amateur stargazers gathers on a hilltop, their telescopes pointed at Orion. Among them is Maya, a high school student, who's been obsessed with Betelgeuse since she first saw it through a friend's telescope. She's read every article about the star's dimming, dreamed of the day it might explode in a supernova visible in broad daylight. Tonight, she's sharing the latest JWST findings with her group. Her voice animated, she explains how the telescope's images show Betelgeuse as a living, breathing entity, not a static point of light. The group is spellbound, their eyes tracing Orion's familiar shape in the sky. Maya points out Betelgeuse's reddish glow, fainter now than it was a few years ago. She wonders aloud if they'll live to see it explode, a once-in-a-lifetime event that could outshine everything else in the sky. The JWST team schedules another observation run, this time focusing on Betelgeuse's outer atmosphere. The telescope's instruments can measure the temperature, density, and composition of the ejected material, offering clues about the star's internal processes. Li Wei and her colleagues are particularly interested in the star's magnetic fields. On Earth, magnetic fields drive solar flares and coronal mass ejections, but in a star as massive as Betelgeuse, they could be exponentially more powerful. If these fields are twisting and snapping, they might explain the star's wild surface fluctuations. The team hopes to map these fields over time, a task only JWST's precision can achieve. Meanwhile, Miguel's students start a project to analyze Betelgeuse's light curves, graphs of its brightness over time. They notice patterns in the data, brief spikes followed by deep dips that don't match traditional models of red supergiant pulsations. One student, Priya, suggests that changes might be tied to localized eruptions on the star's surface, like sunspots but on a colossal scale. Miguel encourages her to dig deeper, and soon she's collaborating with Aisha, sharing data across continents. Together, they propose that Betelgeuse's surface is a patchwork of hot and cool regions, constantly shifting as convection currents churn below. It's a bold idea, and they submit it for peer review, hoping JWST's next images will back them up. In the quiet of her observatory, Aisha reflects on what Betelgeuse means to her. As a child, she saw it as a symbol of the universe's vastness, a reminder that there was so much more to discover. Now, as an astronomer, she sees it as a puzzle, a challenge to everything she's learned. The star's chaotic behavior is forcing her to rethink how massive stars die. She wonders if Betelgeuse is a preview of what's to come for other red supergiants, or if it's an outlier, a cosmic oddity defying all expectations. Either way, JWST's revelations are a turning point. For the first time, humanity can watch a star's final act in real time, not just through distant echoes or theoretical models. Across the ocean, Li Wei presents the latest JWST findings at a global astronomy conference. The room is packed, the air electric with anticipation. She shows the audience Betelgeuse's turbulent surface, its glowing patches and dark scars. She explains how the star's mass ejections are reshaping its outer layers, creating a dynamic environment that could influence nearby star systems. The implications are staggering. If Betelgeuse explodes, its shock waves could compress nearby gas clouds, sparking new star formation. The heavy elements it scatters will drift through the galaxy, perhaps one day forming planets with oceans and atmospheres. Li Wei's voice trembles with excitement as she describes how JWST is rewriting stellar evolution, showing that the end of a star's life is anything but predictable. Maya, watching the conference online, feels a spark of inspiration. She's always loved astronomy, but Betelgeuse's story makes it personal. She starts a blog, sharing JWST's images and what they mean for the universe. Her posts go viral, catching the attention of young stargazers around the world. People will start looking up at Betelgeuse with new eyes, not just as a star but as a cosmic engine, shaping the future of the galaxy. Maya organizes a star party, inviting her community to gaze at Orion and imagine the violent beauty unfolding 640 light-years away. The event draws hundreds, from kids with toy telescopes to retirees who've never looked through one before. They all share a sense of wonder, a connection to something far bigger than themselves. Back at the JWST control room, the team discovers something new. The telescope's latest spectra show traces of heavy metals in Betelgeuse's ejected cloud cell, forged in its core during its long life. This is a clue to what's happening inside the star. As a red supergiant, Betelgeuse is burning through its fuel at a ferocious rate, fusing heavier and heavier elements until it can no longer sustain itself. When that moment comes, it will collapse under its own gravity, triggering a supernova that will outshine entire galaxies for a fleeting moment. The team debates whether this will happen in their lifetimes. Some, like Li Wei, are optimistic, hoping to witness the event. Others, more cautious, point out that stars like Betelgeuse can linger in this phase for thousands of years. Aisha, meanwhile, is grappling with a new question. What happens to the material Betelgeuse is ejecting now? JWST's images show it, drifting into the interstellar medium, but what does that mean for the Orion region? She collaborates with a team studying galactic ecosystems, modeling how Betelgeuse's outbursts might influence nearby molecular clouds. Their simulations suggest that the star's ejected material could seed new star-forming regions, creating a ripple effect across the galaxy. It's a humbling thought. Betelgeuse, even in its decline, is shaping the future, laying the groundwork for new worlds that might one day harbor life at the university. Miguel's students are now fully immersed in the Betelgeuse project Prius. The idea about localized eruptions gains traction, and the team publishes a paper suggesting that Betelgeuse's surface is a chaotic mosaic of convective cells, each one capable of driving massive outbursts. The paper sparks debate in the astronomical community, with some calling it a breakthrough and others demanding more evidence. Miguel beams with pride, knowing his students are pushing the boundaries of science. He reminds them that JWST's data is just the beginning. As the telescope continues its mission, it will capture more images, more spectra, more clues about Betelgeuse's fate. Maya's star party becomes an annual event, drawing crowds from across the region. She starts a podcast, interviewing astronomers, like Aisha and Miguel, sharing their passion with a growing audience. Her listeners send in questions. Will Betelgeuse's supernova be dangerous? How will it look from Earth? Aisha explains that the star is far enough away, 640 light-years, that its explosion poses no threat. Instead, it will be a spectacle, a cosmic fireworks show visible even in daytime. Miguel adds that the supernova will leave behind a dense core, possibly a neutron star, and a nebula of glowing gas that future generations will study. Li Wei's team, meanwhile, is pushing JWST to its limits. They're now tracking Betelgeuse's magnetic fields, using the telescope's sensitive instruments to detect subtle changes in the star's outer atmosphere. The data suggests that magnetic reconnection events, explosive releases of energy, might be driving some of the star's eruptions. It's a new piece of the puzzle, one that could explain why Betelgeuse is so unpredictable. Li Wei shares the findings with Aisha, who incorporates them into her models. Together, they're building a picture of a star in constant flux, its surface and atmosphere reshaping themselves in ways no one could have predicted. As the years pass, Betelgeuse remains a focal point for astronomers and stargazers alike. JW observations continue to pour in, each one adding to the story. The star's surface changes week by week, its brightness fluctuating as new eruptions cast material into space. Aisha, Miguel, and their teams refine their models, learning more about the physics of massive stars. Maya's podcast grows into a global phenomenon, inspiring a new generation to look up and wonder. The star that once seemed so familiar is now a symbol of the universe's unpredictability, a reminder that even the most constant things can surprise us. One clear night, Aisha steps outside her observatory and looks up at Orion. Betelgeuse glows faintly, its reddish light a quiet promise of the chaos within. She thinks about the atoms in her body, forged in stars like this one, and feels a profound connection to the cosmos. Betelgeuse isn't just a star, it's a story, a cycle of birth and death that stretches across billions of years. JWST has given humanity a front-row seat to that story, revealing a universe that's alive, dynamic, and full of surprises. As Aisha gazes upward, she knows this is just the beginning. Betelgeuse may explode tomorrow, or it may linger for centuries, but either way it's teaching us to see the cosmos with new eyes. The James Webb Space Telescope, with its golden mirror and infrared vision, is more than a tool, it's a bridge between humanity and the universe. It shows us stars like Betelgeuse in unprecedented detail, but it also shows us ourselves, our origins, our place in the grand cosmic dance. Every image, every spectrum, is a reminder that we're part of something vast and beautiful. Betelgeuse. Eruptions, its turbulent surface, its uncertain future. They're all part of the same story that began with the Big Bang and continues with every breath we take. As JWST gazes deeper into the cosmos, it invites us to do the same, to question, to explore, and to marvel at the universe that made us.